Hello, this is Group 33, and our topic is database encryption. The database is a widely used tool nowadays. The security of database has been increasingly important. Yahoo data breach is the biggest data breach in history. 3 billion user accounts and users' real name, email address, dates of birth were exposed by the attacker between the year 2013 to 2014. As students who are studying cryptography, we are interested in how the leaks happened and how to protect the data from being stored or stolen from misuse or malicious intent. There are many different techniques to make data safe. Today, we will introduce 3 important areas in database encryption: different level of encryption, symmetric and asymmetric search encryption, and hash function. The first part is different level of encryption. Data encryption algorithm can be implemented on both hardware and software level. For hardware level, specialized hardware uses implemented encryption and decryption algorithm to process read and write requests. For example, IBM S390 cryptographic coprocessor. It uses integrated cryptographic service facility libraries for database encryption. It supports CPU interface, cryptographic engines, and key storage. On software level encryption, it can be applied at various granularities, such as whole database, tables, rows, columns. Here is the first level of encryption, storage level, which is also called transparent data encryption. It stores the entire database in an encrypted format on disk and thus protects the data at rest. It has the advantage to be transparent, thus avoiding any change to existing applications. However, it cannot consider user privileges and data sensitivity. This would be solved using column-level encryption. In column-level encryption, the data is encrypted and decrypted of one or more entire columns. For example, some sensitive data-related columns like user's password, user's privacy requires encryption. Others may not. This schema not only solves the problem mentioned before, but also makes data more secure as each column can have its own unique encryption key. However, it limits available query optimization functions and increased data file size. With the growing popularity of applications, application-level encryption is proposed. The data is encrypted and decrypted on client side before storing it in database. It simplifies the process in database and makes data transmission more secure. But it limits database performance as application cannot read data created by other applications and consume resources on client side.
Now, let me introduce the second part, symmetric and asymmetric searchable encryption. We are all familiar with the symmetric and asymmetric encryption, and there are 2 important features when implement them in database. First is the security, that we want to leak as less information as possible. Second is the searchability. The problem is how to outscore the data in private manner and maintain the ability to selective search over it. We are going to introduce the solution for this question. Since regular private key encryption prevents one from searching over encrypted data, users also lose the ability to selectively retrieve segments of their data. Searchable symmetric encryption, also known as SSE, is the solution to provision symmetric encryption with search capability. The process is that first, data owner encrypts the documents with the symmetric key and sends the ciphertext to database. The database stores those documents. Data owner will share the symmetric key to data users through some authorized third party. For users, they can search the document with the keyword in database through a mechanism called trapdoor. What is a trapdoor? A trapdoor is a function easy to compute in one direction but difficult to compute in the opposite way, without special information. So it means only the user with symmetric key can get the document, and other requirement will be refused. Searching index is one of the approach of SSE. An index is a data structure that stores document collections while supporting efficient keyword search. In this implementation, the trapdoor function is the index. To search for a keyword, the database generates and sends a trapdoor for key, which used to run the searching operation and recovers point to the appropriate encrypted document. Two important conditions for the security index is that trapdoor can only be generated with a secret key. Second, the search operation can only be performed by the process of a trapdoor. Asymmetric searchable encryption, also known as ASE, is a searchable version of asymmetric encryption. It's very similar to SSE, but the trapdoor has different implementation. ASE is often used when the server or database is untrusted, and is often used in email applications. Public key encryption with keyword search, also known as PKS, is an example of ASE. The process is that Bob encrypts his message using Alice's public key. Then, he will encrypt arbitrary number of keywords using PKS. After all, Bob sends both encrypted message and keywords to database. Alice can get the message from database and decrypt with his private key. When Alice wants to search the message in database, she can use the trapdoor function, which requires her private key and the keywords. If the database finds keywords, it will return the ciphertext of the message. Query from attackers will be refused because attackers don't have Alice's private key, so they can't get the encrypted message from database.
For hashing, hashing is also a frequently used technique in database encryption. So what is hashing? Hashing is a transformation of a string of characters into a fixed length value or key that represent the original string. For security hash function, we require that the function should have pre-image resistant, second pre-image resistant, and collision resistant. These three resistance just simply means that if somebody is trying to know any original message that of a given hashed value, it's just impossible. So it's just like if somebody want to get a string of this length, and it's impossible for him to get the original 1, 2, 3 here. So why do we need hashing? When we are storing password in database, it is unwise to store the password in plain text, since if the database is breached, all passwords are leaked. Also, storing passwords in plain text is also vulnerable from insider attack. Instead of storing password in plain text, storing the hash value of password is safer, since the attacker cannot retrieve the original password from hash value. However, just storing the hash value of password is still not safe enough, since the hacker or attacker can use rainbow table attack. So imagine an attacker has a rainbow table like this. So it's all the hash version of the frequently used passwords. So he can just compare the hash value and the hash value here and find the original password. So to prevent this attack, salt and pepper are used. Salt is a random generated string that stores in database in plain text for each user. Each user has a unique salt, which is appended to his password before hashing. The rainbow table is useless in this case since the attacker has to recalculate each salt for each user. If there are 1,000 users in a database, the hacker will need only one table to achieve all the password, but now, because using salt, he needs to generate 1,000 tables to get all the passwords. So pepper is another way to decrease the risk of rainbow table attack, but the use of pepper is controversial and its implementation are highly disputed. So normally there is only one pepper in the system, and it should be kept secret. So similar to salt, it is also added to the password before hashing. That is the end of our presentation. Thank you for your listening.